Okay, so hello guys. Good evening. I think it's good evening. Good afternoon. Yeah. This is our third video. Not video. Sorry. This is our third meetup in our getting started with Kubernetes series. So I hope you guys have already seen the first one. The first one is getting started with Kubernetes, where we have discussed basics of Kubernetes, and we have also talked on how we deploy our application to Kubernetes. And all, in the second section, in the second meetup which we did last Sunday, we were actually talking on the container probes, and we have also uploaded that video. And now we're going to talk on init containers. So we are already familiar with containers, pods, Kubernetes. So if we have little more doubts, maybe we can actually go ahead and then look back up our videos, and then we can actually connect things which we don't understand over here. Okay, so moving forward, so what are the prerequisites? So obviously the container basics is the prerequisites because that comes in Docker basics. So Docker basics in Kubernetes basics is really required. So for us to get more information, like what actually it is and what we are trying to, and this is where we can actually find it out. And we have already shared the video link, right? Sumit, yeah. Yeah. So agenda is pods. So we're not going to talk more on pods, like what are pods, because we already talked last session which we did. So we're going to talk on we have already talked on like what are the one container pods, single container, single pod. So that has been like scenario as of now. So we are going to like make it little more further. So we're going to talk on pods that run multiple containers and they need to run together. So this is the prerequisites for init containers, and then when we have our coming sessions where we can actually have when we have multiple containers use cases, this becomes useful. Yeah, and then we're going to talk on init containers, what init containers are, and we're going to have a demo, and finally QA. So short and simple agenda. Okay, so we're going to talk on what are multi-container pods. So we have already understood, right, what are pods. Like when we say we can compare, right? So if we talk about any object-oriented languages, so object is the main unit, basic unit. For Kubernetes, pod is a basic unit. It's a basic unit which can be scheduled, which can be deployed, which can be even horizontally scaled or even vertically scaled. It can also be replicated. And we all know, right, it's a group of one containers, and they when they are sitting together, and then it's managed by a pod. So they share so many things between them. Then that can be volume, that can be network, and one more thing is that those containers they always sit together. So it's not that one container in one pod sits on another node and then the other one with the other node. So it's not that case. Another thing is that they, as I already said, right, so they share some resources, storage, network, in network IP. So when you have a pod, you have some, let's say three containers, they have same IP, but they will be differentiated by their port number. And then when they have to communicate with each other, they can communicate via localhost. So they can say localhost at port 123 to 123 container, 345 to 344 containers, similarly. Yeah. So I'm moving a little forward because we have discussed all these all things already. So how do we create multiple containers? Okay, how do we create multi-container pods? So it's similar way what we do in our single container pod. So we say kubectl conf and we give a file. And there is another way which we already saw. We can actually do it in imperative way, but we're not going to talk about that because this is like we are going to talk on multi-containers. So this is basics. Yeah. So minus f, you can use minus hyphenating for like if you use this file name, then you can use hyphen and give a file. So what is a file? It's a pod configuration file. There are a few things which remain constant in pod configuration file. One is API version, kind, metadata. So these are this remain constant, and there is name. It also remains constant. You have labels where you specify key values, and then there is a spec. So we're going to talk more on spec. So what is spec? So spec schema is when you create a container, right? So when you create a pod, you have like a spec, right? Pod spec. So when you create the same pod in deployment in some other controllers, you have same spec again attached. So this spec contains containers. Okay, the first directory dictionary we can say or something. It's like first thing is containers, and what does it have? So when you actually do one container per pod, right? So we have definition of single container. So we say that okay, we just try to specify what and all we have for the container and then how will it behave. So it's a list of containers belonging to the pod. So when you see that, it's always containers, right? So containers. And a few facts: containers cannot be added or removed once the pod is created. So you have to like actually create a new one. And to have your pod successful, so minimum one of containers should be there in the pod. Okay, so now coming to a few more theories, like what are the required fields in the containers and what are the optional fields. So the two required fields are name. So you can give any name which satisfies the naming convention, all being lowercase, and then not using underscores. You can use hyphens, and some other are also there. And then there is something called image. So image is like your image of on which your container is going to run. These are two required fields of the container's spec schema. And then when you talk about optional parameters, optional properties, there are commands, there are arguments, environments. So you can actually execute something on top of. For example, you have a Docker file, and if you want to override the command which you are executing inside that, you can actually do it with this. Environment to declare environment variables, and image pull policy. So you might be aware of image pull policy. So there, like by default, there is like a policy called if not present, and then you can, if you want your pod to pull, sorry, in like if you want your kubelet to pull container image every time, you can specify to always. There are ports. So ports configuration, you can put it over here, and then you can use it for your container probes, which you already saw in our last session. This is resources. So resources are like you can actually specify what is the minimum, maximum, and what is the default resource you're going to give. That can be CPU or memory, as in case. In later versions, there is something called huge pages. Maybe we can discuss later. And there is something called restart policies and volumes. So there are many more. So these are a few things which I wanted to highlight. So things, the reason I have done is like this, because restart policies and volumes, they are actually not attached to a container, they are attached to a pod. So when you specify restart policy as always, so this is applied to all the containers inside the pod, and same goes with the volume. Yeah, I hope you guys I hope things are going through, and please feel free to interrupt when you have some questions. Okay, so we are having demos on multi-containers, and we are having demos on init containers. So directly moving to init containers. So what is the reason why you want init containers, and then why there is a separate name called init containers. So yeah, init containers are special containers. So in we might have aware, right? So we might be aware, like we might be knowing like there are a few languages, right? So please let me know if you know more about. So we know object-oriented languages like Java, and then those who follow object-based programming language. So they have something called objects, and they have something called constructors. So the main purpose of constructor is to do some initializations to your object so that your methods and objects perform like they perform well. So and that's what we can actually have an analogy that initialization part is done by init containers. So initialization is like you have your application, and then you want to do some initialization. For example, you want to actually for example in constructors, right? So you do all your DB connections, and you do DB seedings in your constructors. You do initialization, you give values to your variables in constructors, but and rest of the part you do it in your methods. So same thing is it is taken care by init containers. So you are going to do, for example, you have let's say example, you have Elasticsearch container, and you want to set some parameters, kernel level parameters. So you don't do it in your Elasticsearch container, you create an init container. So the idea behind is just to actually decouple your startup procedure and your running logic. That's the only reason. And as I already said, so they can contain utility setup scripts, and then which you don't want to put it in app image. And you want to decouple. And this allows you to make changes. Yeah. So as I already told. Okay. And one more thing is that like you are actually not mixing up both. So it's all three covers the same thing, and it is always required for your main application. And also similar to constructor, it is the first thing which runs before your application runs, and it is always done only once when your application is starting. Yeah. So what are the init containers design considerations? So as I already told, they always get executed before any other container in the pod. they always run to completion, so they don't have life cycle. So you might have seen, right? So you have a pending phase, you have a running phase, and you have succeeded. So succeeded, and then they complete. So there is no state called running for them. And for example, it's like you have init containers, right? So it's not that you have single init container, you can have multiple init containers. For example, you have a complex thing, you have so many prerequisites to be done for application, so you can break down that prerequisites in different containers, and then you can execute. So when you do that, they are executed in sequence, and they all are dependent on each other until and your first executes, it doesn't move to the second one. Yeah, and one more thing is that if your init container fail, your pod is restarted. So pod is restarted means you're restarting all the containers inside the pod, means you're again executing your init containers. Yeah, so any questions as of now? I mean, if I'm going fast or anything which is like not understood, if anybody wants to ask something. If not, then I'll be moving. Yeah, and how is it different? So the resource request and limits for a container are handled differently. This means that, for example, you might be like we already discussed, right? So what are the optional parameters? What are the parameters which we are specifying for a container? And resources are one of them. So you can actually independently specify resources for your init containers and for like differently for different containers, right? So now, for example, you are specifying limits, resources and limits, resource requests and resource limits for your init containers, and similarly you're applying for your application containers, and you know what? So the priority goes first to the init containers. So while scheduling, right? So the requirement on which it is scheduled is the resources requested in your limit init container. So if you have for example, if you have your init containers taking more resources, and then it's not able to find any node, but your application is having resources which is matching the node. So in that case, your application doesn't get scheduled. So you have to take care of that. So it's like it's just like a priority since it is run first. So it is getting the priority also first. So on its basis, it is actually getting rescheduled, not rescheduled, scheduled. They do not support lifecycle, so because they run to complete, and they do not support readiness and liveness. It's same because they don't have a lifecycle. Okay, and so few sample use cases. It's like why do you think we need? There is a question like why do you think we need init containers? So as I already said, we just need to decouple the logic, like your application and your startup logic. So you have an application which actually depends on Redis, which also depends on your maybe Redis, maybe Mongo, many other backing services, and it needs that to come up before it comes up. So you can actually put an init container which actually checks it and then waits till it comes up until when it comes up, it starts your pod creation. So this can be again same can be achieved by your probes, but it's always good to like segregate, and then it gives you more feature. So we'll be having this in demo. Run DB migrations and seeding a database. Sorry, spelling mistake. It's seeding. That means, for example, you have your application code and you have something running in production, and you do some schema changes. So you want your schema changes to go first, and then later you actually start your applications. So instead of putting this migration in your application, you can actually decouple it, and you just know, okay, whether it actually succeeded, and then only you go to running. Seeding database means you're actually pre-populating data to your database so that you can just see the query performance. What is the query like? How much time it does take? Response time. And one more use case can be like you can actually use the init containers to wait for some time and give a time for your application to start. Like we actually used startup probes and other like probes and initial data seconds in other two probes. So you can use it for that purpose. So you just go ahead and like, okay, you create a container and then you actually wait for some time. So you know that, okay, it is this much amount of time it is going to take. You just sleep for some time or you just like halt for some time. Okay, so decouple application logic and startup procedure. So this is again repeating. Okay, so how do you debug init containers? So this is all theory. We are going to see it in practical. So the way is like, how do you know what containers are? So when you actually specify, you can actually go ahead and then kubectl describe, and when you do pod and then give a pod name and obviously namespace, then you'll get the list of containers inside that pod. And if you want to see the logs, so kubectl logs minus, if you want to put -f, it will give you tailf kind of feature. And if you and -c for the container name. So it goes same for the multiple containers, and then you can actually use it to see. So in this case, I didn't use -f because that container is got to go to complete and it's not always running. So you can use this particular command for if you have multiple containers and if you want to debug each of them. Yeah, and before telling this, one more thing I want to tell is, for example, you have your init containers in place and you have something in production. So, and for some reason, you are going to change the, you want to change the image of the init containers. So that is literally dangerous, because any change to an specification of init container is going to restart your pod. So restarting your pod means that it's actually going to restart every pod inside, every container inside your pod. Yeah, so this is how do you understand the pod status? There are a few things. So if you have init n by m, so it will be always like n is like, so m is the total number of init containers inside your pod. If you have one, it will be one. And then n is that how many pods are ready at that point of time. I mean, it's not ready, it's completed because it runs to completed. Error means your init container is failed. You can go ahead and you just have to describe the pod and then go ahead and check it. Also, you have to use the logs option to check the error, what it is actually giving it. There's a class loop back off. It is exactly same as class loop back off in your pods, in your containers. In this case, there is init container. Pending phase, yeah. We already know, right? So pending phase, like until unless your application gets bound to a node and your image is being pulled, it stays in pending phase. Pod initializing or running. So it means that if, for example, if you have 10 init containers, all of them are successfully completed and it is going to start your application container. Cool. So guys, anything to ask us till now? Hello guys, welcome to the demo section of Init Containers. The first thing we're going to do is we're going to create another folder. So we already saw for multi-containers. Now we're going to do a sample demo on init containers, and we have already have a session on our theories, so which is in the previous minutes of this video. And then first thing it is always good to is we're going to create a namespace named init-containers-demo. So kubectl create namespace init-containers-demo. And then second thing we are going to do is we're going to just set the context to the newly created namespace, which is init-containers-demo. So this will get us context switch to that particular namespace. And now let's do some prerequisites checks, that is kubectl get pods, just to check if we don't have any pods, and then this is a new namespace. And we are going to create a pod which has an application container application, and then that application requires two services. So in this case, that is Redis and then Mongo. So we are going to use init containers just to make sure that first thing what my init container does is just waits for my Redis and Mongo to be up. Only after that my application starts. So this is how I create a pod spec. So API version, kind, metadata, name, spec. In the spec there are two mandatory contents, name and image. So in this case I'm going to take a BCBox image, and I'm going to for a sake I'm going to execute a command and sleep for some time so that it keeps on running. So this is how I do it. So I say echo and I say hello world, and a simple message which will actually written on the log. It will be written on a standard out. Yeah. So we are sleeping it for some time, and then we are just giving a message, I need Redis to restart. So let's start with the Redis first. Now this is how we define the init container. So we say init containers, it can be one or more. Similar to the containers, we give a name. So we are going to give a name as a Redis check. We're going to use the same image because we're going to execute a command, just a small simple bash command. So in this that will be like similarly how we did in our containers. So we say args and we specify the shell bin bash, bin sh in my case, -c. Now I'm going to wait until my ns lookup passes. When I do ns lookup to Redis, it passes. If it doesn't pass, it'll actually keep on running the same command. So what I'm doing is I'm just actually doing it ns lookup. It's a simple command. What actually it does is it'll just keep on checking if my service is up or not. So how do I apply my configuration? So you can just say kubectl apply -f and give a pod.yaml. So in the first case, my application is just only waiting for Redis to be up. So when you see, right, so when you see the kubectl get pod, it is in init 01 because there is only one init container, and since there is one init container, zero of the containers are in success state. So now my Redis check is started, but due to some reason it is not going to it is not initializing my application container. So how do I see the logs? kubectl logs -f container name -c hyphen the application container which is the init container name. So as you can see, this is throwing that error, so waiting for Redis because Redis is not there, and the service we have not created for Redis as of now. So what we're going to do is we're just going to create a service. So it is a Redis service. So we already know what service is. So service is like when you create a service, you get a DNS and an IP. So that is what we want. That is what we are waiting for in our. That is what our init containers are waiting for in our pod.yaml. So this is how we define a service: API version v1 kind service metadata, and let's give a name Redis because we are using the name Redis. Selector, we can give any selector. So we are just concerned on our API endpoint. So it's a service endpoint. So we give a port, any port for the service, and then 6379 for my Redis. So this should give me a minimal Redis service. So kubectl apply -f should give me my Redis started. Now let me do kubectl get pods, and then it will take some time. After that, if after that the condition is met. So as you can see, I think it is already met, and my pod gets initialized. So if you're going to know more what actually is happening behind the scenes, you can do kubectl describe pods and give the pod name. So you can see, right? So your first init containers are executed first. So your Redis check is already done, it is successful, and only after that your container image, your application container is running. Now next thing what we're going to do is we're going to add one more container, init container. So let's put it in let's copy and paste, and let's make it as a Mongo check. So this is how actually you add it. So it's just adding another spec for your container, and you just change few things. That is, you change the service name over here, you're putting it to Mongo, and here also you need to change, and that will suffice. kubectl apply -f. Okay, so since it is a pod, it will not apply by itself. So you have to first delete the pod, because in so but pods by themselves they don't give a declarative update. It's unlike deployment. So kubectl delete pod, and pod name will delete the pod, and then apply -f pod.yaml will apply it, and get pods will give me the status. So we can see there are 2 init containers in total, and as of now none of them are succeeding. Now we wait for some time. Ideally, as per the demo, my Redis check should pass, and after that Redis check being passed, it should go to Mongo check. So it is going to Mongo check. One of the 2 is successful, but the second is not successful because there is no service as Mongo. So the first thing we're going to do is we have to create the service. Only after my Mongo service is up, it actually starts the application. So similarly, as we did for Mongo check, Redis check, we can do it for Mongo check to check if check the logs. And what we are going to do is we are going to create a new service with some Mongo service. We just copied everything from redis.yaml and put it in Mongo. Change few things, just change name, and that should do. You can even change the port. kubectl apply -f. Mongo.yaml will get me the Mongo service created, and ideally after this my pod should start. It should start actually. It should even go for, it should pass Mongo check. After Mongo check being passed, it should initialize the pod. As you can see, it is in pod initializing phase. A pod moves in initializing phase when all of your containers which are in init containers, they have successfully run. So this is how it looks like. Yeah, now so we'll do a cleanup activity for this. So how do we clean up? So the best thing what I do is, like, because I'm using it over here in development mode, I just go ahead and delete that namespace which contains all the resources which I created. So it's not recommended to you to delete a namespace, but I'm doing it because it's a demo purpose. So kubectl delete namespace, give the name of the namespace. Now it should clean up. After cleaning up, we should move to the second demo of init containers. That is a use case. So we can say that new make a directory called use case. We go inside this. We are going to create an Elasticsearch cluster which has a master data, master nodes, and a client node. So we make direct call es, and then we make a directory called master. We go inside that, and there are a few things which we are going to create it over here. So first thing is that we are going to go to our repo, that is alias 687 case.elk. This is what it is. We go to es folder. Here we go to master nodes, and there are a few things: configmap and deployment. Configmap to carry configuration for master node, and deployment for a master node configurations, pod specification. So when you see this, it has this is how it has. So when you do wget, and then you should be able to download that file. Now we are going for a deployment. We'll go to deployment, and we'll make it raw, so that we can actually use wget on top of it. So config map we already created. Will be now we already downloaded. So we have downloaded deployment.yaml. Oops, I think we downloaded the wrong file in config map. So first thing we are going to do is, let's make it raw and then download it for config map as well. We go back. Deployment.yaml looks fine. So config.map.yaml looks in bad shape. So we removed it. Go to configmap.yaml, make it raw, and download it. So it contains few things like configuration specific to master, Elasticsearch configuration. Now things looks good. There is a cluster name, there is a service. It's a headless service. What is a headless service? Headless service is a service which has cluster IP, none as a cluster IP. This is being like in Elasticsearch configurations, we need to have this discovery directive which contains the IP and port for your other nodes. So that helps in like node discovery for Elasticsearch internal communication. So there are two things. One is service, that is a headless service. Another is so as you can see, headless service, the name of the headless service es. So we are going to download it for master. This is the service because it will be used as a service discovery, and we also need this limit because we want to put a limit on pods, at least in my case, because my system is with less memory. So this is one of the way to like avoid my system hang. So again, we'll start with creating a namespace. Let's create a namespace called init. Let's name it something like Init Containers. So we can name it as Init Containers, and we can again we have to let's set this context. So this is how we do it. We have already done it. After that, so let's start creating all the API objects one by one. The first API objects we should create is we should create a limit range, because we have not done any resource definition in a pod spec. We create a config map, so we can see we need ES, that is a headless service. So first after this we gotta create service, that is like we can create a headless service or config map in whatever order, but it is always good to create a service first. So this particular service has port 9300, which is used for internal communication by Elasticsearch. Now when we apply it, we get a service created. Third thing we're gonna do is we are left with one more manifest, that is deployment.yaml. So now we should be good with our ES master, and ES master has init container. So when we see this init container, that is sysctl-config, what it does, it in this case the use case of the init container is just to set like kernel parameters. In this, it is actually creating setting a max memory map count to the maximum. So Elasticsearch requires that there are so many other parameters which is not in this video's scope. So this is how it looks like, and after that you have your own container. So it is like in similar way. So maybe you can ignore this security context, because this is for privileged containers. There will be another session on privileged containers and unprivileged containers. So this is like, since Elasticsearch uses some kernel level parameters, so it is necessary to make it as a privileged container. And there is a config map. This is how it is mounted to a master. When we do kubectl get pods, ideally because there should be no problem and it should be running. So in some time it should be running. If you want to go ahead and check the logs, kubectl describe pod to get the pod descriptions, and logs -f to get the pod logs. So as of now my readiness probe is failing because Elasticsearch really takes little time to actually start, but as you can see, my init containers passed. So since they have paused, that's the reason my application ES master started up. Now we are interested in getting the logs, why it is actually not started up till now. So one more thing, you can just check what actually was in your sysctl config. So this is what sysctl config was giving. So it is actually setting this particular sysctl configuration in my pod. So they all share the same, they both run in shared context. So this is applied to the second container, which is ES master. So we have created all these stuff. So now what we are going to do is we are going to make another directory called data. So we have created master, we need a data. So when you go inside the data, there are a few things which we require. One is obviously config map. So we can get the config map, which is actually a specific configuration to a DataNode. So we can go to DataNodes, we can make it raw. I mean, maybe it's good to open in new tab, both in new tabs, and make both as a raw. And as you can see, there is like, again, this particular config map is using ES. As I already told, it should be same across all the nodes. So when we do wget for this, and similarly we have to do for the stateful set. So we are using DataNode as a stateful set. Stateful set we'll be discussing in our later coming sections. As of now, you can actually assume add as deployments with durability, and yeah. So both of it is actually created. And so first thing we're going to do is apply. Let's apply config map. And there is a one change we want to do it in stateful sets. So you can see the configurations which we already saw in master. It's same. There is a security context we have put it, and we have to we know one more thing we have to do is our data node must not come before our master node. So we want to have one init containers which is just going to check if my ES service is up or not. Unless my ES service is up, there is no point creating a data node. So I use bcbox, and again I use args, and then similarly I'll write few commands which will actually like it will actually check if my service is being created. That is a ES service which is used in every config map of my, either it is data node, master node, or any other node which I'm bringing in. So what I'm going to do is we're going to use ns lookup. So when my service is created, my init container moves to the second init container, which is the serial config. It sets the kernel level parameters, and after kernel level parameters are being set, then it starts the data ES data node. So this is how it works. So in this case, ideally it should not fail because we already have ES service in place, and then when you do the WQ, it should be good to go. So this is ES master we have, and we apply for a stateful sets. Yeah, and it is applied without any errors. Get pod should give me es-data.0, and there are two init containers. 0 of 2 is successful. Describe pod will give us the detailed information. So my container service check is passed. It is moving to the second check, in which it is actually again pulling a new image busybox, and then it is setting the kernel level parameters. So logs -f, similarly how we did, it will actually be helpful to do it in oops, there is an error. So this is what it helps. So what we can do, we can go inside the stateful sets.yaml and correct it. So there is no do, we have not used do, so I think so we have to use do over here. Yeah, so that's the best thing of logs. Logs give you so many things. They help you make things better. Okay, so it's always good to delete. Let me delete in this case for the first place. kubectl delete sts stateful sets es-data, and kubectl apply -f stateful sets.yaml. Now everything should be fine. Looks fine. Describe pod es-data-0. So the name of the stateful sets remains same. We have service set created. It is executing that command to do ns lookup. Logs, so you can see till now it's not able to do it. It's not able to ns lookup for some reason. So let's wait for some more time. Let's do kubectl get pods. Maybe you can use. Okay, so after some time when you can see, right, so service check is passed. It is actually going for serial config, that is also passed. Now my ES data is started, and just after that it takes time to get up your application. So readiness probe has kicked in. Maybe we can use the initial delay seconds a little more, or maybe we can use startup probe in this case to avoid readiness probe kicking in. So there is no problem readiness probe being kicked in because it's not restarting your container, it's just not adding it to endpoints. So we can see my application has started, but my probe is failing. That is readiness probe. Kube logs -f will give me the logs. As you can see, it is still starting. So fail to clear the case. Maybe we can wait for a little more time, and we can see it has started. So after starting it, I should get 101. Means I should get my probes passing. So my readiness probe passes, then only I can actually get 101. So another thing is that we also wanted to expose a service so that actually we can actually do a curl. So for that, we're copying a headless service to spc.yaml. We make few changes in this. What we are going to make changes, like let's make the change as http.es-http, because we are going to actually use it on 9200. We may actually delete this, we don't need it, and we specify a target port over here. The target port is 9200. So on 9200 we can actually communicate over APIs. So 9200 we can have this any port, so let's make it 9200 in, so as to become uniform, and give a node port so that we can access it from our local. After this, we apply it, and so we have used the ESS-master as a selector, so it will be actually connecting to my master. So in this case it is fine to whichever it connects. So curl localhost 9.31237 should give me a result. It's like localhost localhost 9200. So you can see we have a cluster supergun and we have a cluster created. So we want to know nodes, so you can do cat nodes. This is, so we can see there is a data node and a master node. Start denotes it's a master node. So this is all for this demo, guys, and thank you for being with us. Hello guys, welcome to the demo section of multi-container pods. So the first thing we are going to do is we are going to check the namespaces which is already created. So we do kubectl get namespace. Okay, so before going to the namespace, let's go and understand what application we are going to deploy. So there is an application called Fibonacci. It's a Flash application, and this is the manifest.yaml for my application. So in this manifest, we are creating a namespace called Fibo, and there is another API object we are creating. It's a service. What the service is doing, it's an exposing the application which we are deploying to a node port, and this is the deployment manifest. The name of the deployment is Fibo, and we have a label called Fibonacci. We have a replicas, and then this is the main application container. We can see Fibo API 1. We also have a liveness probe defined over here, as we have already discussed about liveness probe. We also have resources defined, so limits and request. There is another container called sidecar container, which is an nginx in this case. So it is like we have same attributes for a container over here, but we have a volume mount which has etc nginx is mounted as a Configmap, and we also have a liveness probe. The whole purpose of this sidecar container is to actually proxy to the application. So when you use your application, it actually first hits the nginx, which is hits the service which is actually pointing to your nginx, and then it proxies to your application which is running on 8080. So the first thing we're going to do is we're going to take up this application code from here, and then let's go ahead and make a directory called InitContainers. We'll go inside the directory, and let's clear the screen. So we are going to make another directory called multi-container. We'll go inside this, and we are going to download this artifact which we have just seen and gone through. So doing ls will give us Fibonacci-k8s.yaml, that is the name. And again, if you want to go through, we already went through. So this is how it looks like. So whole thing which we wanted to describe is like how do we define a multi-container pod. So this is how we define, and we already have discussed about the theory in the theory section. The kubectl apply -f will create all these artifacts, API objects, namespace, service, deployments, configmap, etc. So first thing we're going to do is we're going to check kubectl get service. So it is exposing a service. And one more thing which I like is I will just change the namespace context. So we can change the namespace context by kubectl config set -context -current and -FN namespace equals to the name of the namespace, which is in this case is Fibo. So let's get to see what are pods. Now we can see there are 2 replicas, and we also see the config map, which is the configuration, which is the Nginx configuration where we have defined the proxy configurations. For example, your service will receive request on 80 port, and then that particular Nginx, it will redirect the request to a Flask application which is running on a different port, that is slash 8080. That is 8080. So now to know more on what are the containers available in my pod, we can just go ahead and do kubectl describe pods and then pod name. So we can see this is like there are 2 containers which already saw, and then in this case if you want to know more, we can see it is pulling the image, and it takes time to pull the image, and it is still in container creating state. So after some time when we see, it will be like in a running state, and when you describe, we'll get to know what and all happened in my pod. Okay, so since we have 2 containers, so how do I go inside one of the containers? You can just do kubectl exec -it, give a pod name. If it is single container, it goes to the container, first container, which is already defined. But if it is 2 containers, you have to define the name. So there are 2 containers. One is Fibo API, and another is a sidecar. So we can go ahead and go into any of the containers which we want. So I can copy the name from here. The other one is Nginx sidecar. So you can get it over here. Yeah. So coming over here, and when we need to give a -c option, and we give a Fibo API. So when we do this, we are inside that particular container, which is Fibo API. So ls will give us all the details over here, and from here I'm not able to actually access that because I have not mounted it. Since Nginx is not a directory, it should be like since it is a directory, it should be cd. So what we'll do, we'll go ahead and go inside Nginx sidecar. So when we go inside Nginx sidecar, and just to verify if the name is correct, yeah, we just copy from here and we go inside the container. So since we have already discussed in the theory, so how do you like place 2 containers in a pod spec? That's how it looks. And now we are inside the second container of the same pod, and if you want to go inside /etc, we can see Nginx configuration. So when we go inside, we can see nginx.conf, and depending upon what command is available, we can actually go ahead and see the configuration. So vi is not available, I think. So cat nginx.conf will give us the details of the config map. So as you can see, it is like root is proxying to localhost 8080, and multi-containers, they also share the same, they share the network's namespace. In this case, they can communicate with each other on localhost, so as it is doing. So our main pod is running on 8080, and Nginx pod is running on 80, and then this is how it is proxying. So to know more, you can actually do just kubectl get pod -o/yaml, and similarly you can do it for your deployment. So that is how you get more information on your pod specification, which has all other things which you have not defined in your pod specification, but it is a default thing which comes up with the when you actually create your pod or a deployment. So in this case, we had created a deployment, so that is how it looks like. So this is how if you go through each, it looks like this. So you can see the labels as a Fibonacci, purpose equals to Fibonacci, and you can give any label key value pair depending upon your use case. So in this case, it is showing in JSON. You can actually convert it into YAML. Now you can see the container port for this one, and there are 2 container ports. One is for Fibo API and another is for Nginx sidecar. So the only purpose is like one of the use case which we are trying to show is like we want to actually do a proxy pass and to a container. So in this case, my application itself is not able to handle a request directly from an API endpoint. So that's the reason we are using it. Yeah, so this is all we have for our multi-container pods, and we can see the config map being mapped over here. So this is all for this demo, guys, and thank you for being with us. And yeah, so keep watching. Please like, share, and subscribe, and take care. Good day. Goodbye.